Problem 16 from Chapter 3 OPENSTAX chemistry textbook wants to know the moles of compound and the moles of each type of atom in glycine. So this is an amino acid glycine. We're going to do part B here. You can look at the description in this video to link to the other parts if you're interested in parts A or C or D or E. Now the first thing we need to do is calculate the formula weight of this substance. And we have the formula C2H5NO2. So the way we do this is we take the subscripts in the chemical formula and we multiply it by the average atomic mass that we find in the periodic table. As you know, I like to use the periodic table found on ptable.com as a source of my atomic masses. For hydrogen, we have 5. For nitrogen, we just have one of those, 14.007. For oxygen, we have 2 of those. And don't forget, the final step is to always add these masses up together. And that will be the formula weight for this compound in units of grams per mole. So I'll punch these in here on my calculator. Okay, and I get 75.067. All right, so that's in units of grams per mole. I'm going to write 1 mole on the bottom of this fraction just to, kind of emphasize that this is actually a conversion factor that can be written in one of 2 ways. Let's now convert grams to moles. So that was step 1, finding the formula weight. Step 2 is to convert grams to moles. So we have 3.06 times 10 to the minus 3 grams of this crazy looking formula. Okay, and we want to set up our conversion factor. Now we're going to have to flip that fraction over so that we have 1 mole on top of the fraction. And we have our grams on the bottom. Grams cancels. And I like to write the full chemical name so you can see that it's corresponding to this formula weight of the whole formula. So on our calculator, go ahead and type in 306, 10 to the minus 3 divided by 75.067. And we're going to round this result to 3 sig figs because the starting quantity has 3 significant figures. So that's going to be the substance glycine. All right, so that's one of the answers we're interested in. Now we also want to know the atom types, the moles of atoms. So we want to convert from moles to moles. Now we do that, let's do, carbon first. In the formula, we know that there are 2 moles of carbon because there's a subscript of 2 in the whole formula C2H5NO2. So the way we set this up is we write out 4.08 times 10 to the minus 5th moles, and we write out this whole long formula. Okay, write a multiplication sign in your fraction bar, and then we want to position these 2 quantities on either side of that fraction bar so that the starting units cancel. So up on top, we're going to have 2. And so basically what we're doing is we're just multiplying the previous quantity in the purple box by 2. And that will equal the moles of carbon. Now all of these quantities we want to keep in 3 sig figs. So that will be one answer. Moles of hydrogen is similar. Now when we do moles of hydrogen, we look at the chemical formula and we can see for glycine, 5 moles of hydrogen is equivalent to 1 mole of C2H5NO2. Okay, so when we set up the conversion, it's going to look like this. Okay, and we want to position the 5 moles of H on top and 1 mole of the C2H5NO2 on the bottom. Okay, so 4.08 times 10 to the minus 5 times 5 is equal to 2.04 times 10 to the minus 4, and that's moles of hydrogen. Now, because the nitrogen has a subscript of 1, the number is going to be the same. You could show the work and everything like I'm doing it here if you like. I'm kind of out of room, so I will just make a note of that. There's going to be 4.08 times 10 to the minus 5th moles of nitrogen. And we know that because the subscript for nitrogen is just 1. It's not shown. Now for oxygen, we have 2, a subscript of 2. So to calculate moles of oxygen, we need to realize that there's 2 moles of oxygen per 1 mole of this C2H5NO2. So when we set this up, it's going to look like this: 4.08 times 10 to the minus 5 moles of C2H5NO2, okay, multiply by, and we're going to have 2 moles of oxygen on top and 1 mole of the C2H5NO2 on the bottom, right? So moles of the starting compound cancel, and we will be left with 4.08 times 10 to the minus 5 times 2, and that's going to be equal to 8.16 times 10 to the minus 5 moles of oxygen. Now you'll notice that the oxygen moles is the same as the carbon moles, because if you look at the chemical formula, there is 2 moles of carbon and 2 moles of oxygen in the starting formula C2H5NO2. Anyway, it's a lot of work to show on one page, but I hope you get the idea. Thanks for watching, and please consider subscribing.